Hello everybody, let's continue our discussion about right triangle trigonometry. One of the questions that people ask me a lot is they'll give me a well-known triangle like a 3, 4, 5 triangle or a 5, 12, 13 or something like that. And a question I get from people a lot is this a 30, 60, 90 triangle? And hopefully this is a really easy answer for you. The question is that a 30-degree angle and is that a 60-degree angle? Hopefully you can look at this and you can see, no, this is not a 30, 60, 90 triangle, okay? If you notice, you don't double the short leg to get the hypotenuse. You're not multiplying the short leg by radical 3. If it doesn't follow the patterns for 45, 45, 90 or 30, 60, 90, it's not one of those triangles, okay? So the follow-up then is people say, well, what are the angle measures for a 3, 4, 5 triangle and how would you find those? So I want to look at how that would work. All right, first of all, you can write a trig equation for this, but remember a trig equation only involves two sides of a triangle and one angle measure. So I'm going to try to find this angle measure right here. It literally does not matter what two sides I use, so I'm going to get rid of the 4 for the time being. I'm just going to look at the 3 and the 5, and literally it does not matter. Pick any two sides. The rule that you're going to use will change, but the final answer should stay the same. All right, so like normal, we're going to use our SOHCAHTOA rules, and we're going to decide, do we have an opposite over hypotenuse, an adjacent over hypotenuse, or an opposite over adjacent, okay? I left the side that is across from the x, which is opposite, and the longest side, which is the hypotenuse. So I have opposite over hypotenuse. This is a sine relationship, okay? So you fill the values into your trig equation. But notice something. You normally take the sine, cosine, or tangent of an angle. We don't know the angle measure. We just know that it's an x, okay? And sine is opposite over hypotenuse. We get 3 over 5, okay? Actually, if you remember when we first learned the trig definitions, you were writing these fractions, and they seem like a total waste of time because you said, okay, great, the sine's 3/5. That tells me nothing new, okay? But what I didn't tell you is you can actually use those statements to find angle measures as well, okay? So let me show you how to do this. And I need to go back to your Algebra 1 course just briefly before I show you something. So sine, cosine, and tangent are functions, okay? If you remember your definition of function from Algebra 1, a function is basically a rule that takes an input and gives you exactly one output, okay? You put something in, it gives something out, okay? You put an angle measure in to a trig function, and it gives you out a decimal that represents a fractional comparison of two sides. So if I knew what this angle measure was, if I took the sine of it, I should get 0.6, okay? Now, back in the old days, people had sine, cosine, and tangent tables, and you could just go on the sine table, and you could look and see, this is 0.6 as a decimal, and you could just go look and see the sine of which angle would give you 0.6 and you'd be done, okay? This is a case where calculators actually make this type of thing slightly tougher, but we'll also be able to deal with decimal values, which we really couldn't have done with the old charts. You could have only done whole numbers with those. But I think there's actually a chart in your book if you want to go take a look at that. Anyway, so here's how this works. You normally put in an angle and you get out a fraction or a decimal, okay? I'm not sure if you talked about these in Algebra 1 or not. I know you'll talk about these in Algebra 2, but there's something called an inverse function. And an inverse function switches the input and the output. So for example, if I have a function, let's say I put in a 2 and my function gives me out a 7. The inverse function, I would put in a 7 and it would give me back a 2. Okay, it just undoes whatever the original function does. So like a really low level version of this, let's say you had a function that doubled a number. So if I put in 5, it doubles it and gives me 10. The inverse function would take half of the number, it would undo that. So I would put in 10, it would take half of it and it would give me back 5. So you're switching your input and your output, okay? Same kind of thing here. We're gonna be using inverse trig functions. Instead of putting in an angle and getting out a decimal, we're going to put in the decimal or fraction and we're going to get back the angle measure, okay? So how does your calculator do this? Your calculator, you may notice, at least most of your calculators, above the sine and cosine and tangent buttons, you're going to see a little sine with a -1 and a little cosine with a -1 and a little tangent with a -1. Those are the inverse trig functions, okay? So you have sine with a -1, read as inverse sine, okay? Cosine with a -1, read as inverse cosine, and the tangent with the little -1, read as inverse tangent, okay? And the way these are going to work, you're going to put in the decimal, it gives you back the angle, okay? So when I take an inverse sine, I'm really saying I want the angle that has a sine of 3/5. That's really what it's doing, okay? By the way, a little other terminology here. Different books will use different notations. Your calculator probably uses the little -1 symbol. Some books will call this an arc sine, okay? It's the reverse of the sine, okay? These are the same thing, okay? So if you ever see an arc cosine or an arc tangent, they're asking you to take an inverse, okay? By the way, one additional thing, and this is probably going off in the weeds, but I just want to mention it. Normally when you take a number to a -1 power, which is what it looks like this is doing, like if I take 4 to the -1 power, it's a reciprocal, it gives me 1/4, okay? This is not taking something to the -1 power, okay? I am not taking the reciprocal of 3/5 and getting back 5/3, okay? Unfortunately, some idiot somewhere decided to use the -1 exponent symbol to mean inverses in some cases, and in other cases it's -1 exponent, okay? So just be careful here. It's an inverse sine. This is not a reciprocal. You're not taking it to -1 power. Don't try doing that on your calculator. You'll get an answer that doesn't make any sense, okay? So let's do this. All you have to do here, the inverse sine just lets you switch the input and the output, okay? So you'll hit the second button on your calculator to get the inverse sine, and you're going to type in 3/5, and it's going to give you back the x value, okay? We just switch the input and the output. So I'm going to put in the decimal. You can put in 3/5 or you can put in 0.6. So you'll hit second, you'll hit the sine button. You should see the little sine inverse symbol show up, and you can type in 3/5 or 0.6, and it's going to tell you that x is about 36.869 degrees. This is not a catchy angle measure. These are not nice angle measures. We don't talk about the angle measures of 3, 4, 5 triangles because they're ugly things like 36.869. Okay? If we subtract this from 90, you can find the measure of the other angle. So this is going to be about a 53.13 degree angle. This is going to be about a 36.87 degree angle. Okay? Nothing catchy on the 3, 4, 5. That's all that's going on here. Okay? Let's try one more example. Okay, so let's say that you have a triangle here, and you have this side length is 5, and this side length here is, I would do a little 5, 12, 13 triangle, and you want to find that angle measure. Okay? You just have to decide the rule. Is it a sine, a cosine, or a tangent? We've got the opposite and the adjacent, so it's a tangent of the angle equals opposite over adjacent, 5/12, okay? So you pick your rule the same way as normal, you fill it in the same way as normal, but I can't type tangent of x into my calculator, okay? I want to put in the 5/12. So you go to the inverse tangent, also known as the arc tangent, and that lets you switch the 5/12 and the x. Okay, so hit the second button, hit your tangent button, type in your 5/12, or if you want to type in the decimal for 5/12, and it's going to tell us that x is approximately 22.62 degrees. Okay, so that's how the inverse trig functions work. They basically get you angle measures. Anytime you need angle measures, it's a great option to consider.